Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about the concept of R squared, otherwise known as the coefficient of determination. We will use the dinner plate size as data to talk about this learning goal. Remember that the correlation, often denoted by the letter R, is 0.604 for this data set. If you square that number, you literally get R squared, 0.365. That value is known either as R squared or the coefficient of determination. What does that value mean? Well, R squared is the percent of variation in plate sizes that's accounted for by year. So if we think of all the different variations that there are in plate sizes, why some are big and some are small, the year of manufacture accounts for about 36.5% of all the differences in plate sizes that we see. If that number was 100%, then all the dots would fall exactly on the line, and we could say we can predict precisely what the plate size is. In this case, year does a reasonably good job of predicting plate size, accounting for 36.5% of the variation. There is another, more complicated way to get the value of R squared, but a way that gives more insight into why the interpretation is what it is in terms of percent of variation. To get this, find the sum of the squared residuals. Some people call this SSE, or the sum of the squared error from the regression line. You can also find the sum of the squared residuals from a horizontal line, a line with slope 0. In this case, that's 3.51. Calculate how much the sum of squared errors from the regression line has changed from a line that was at 0 slope. So 3.51 minus 2.23 gives you 1.28. And then you can make that difference a percentage. So 1.28 divided by 3.51, the total sum of the squared residuals from a horizontal regression line gives you 36.5%. The correlation and regression applet, part of the ISI set of applets, helps you through this computation by putting a horizontal line on the graph and showing you the sum of the squared error, or sum of the squared residuals, visually. The best possible R squared is 100%. This will happen if all the dots are on the line. Some research has as its goal to have a maximum R squared. Others, the goal is not a maximum R squared, it's not a maximum predictive ability, and so we don't worry as much about R squared in those cases.